Hello everyone and welcome to special right triangles. So the first example, this is a special right triangle with two congruent sides. So for example, in my picture I'm going to mark those with little tick marks, and that means that those are equal. If you think about it, what would the angle measures have to be? Clearly the last angle is going to be 90 degrees, and both of these would be 45 degrees each. So this would be a 45, 45, 90 right triangle, and this is called a 45, 45, 90 right triangle. So let's move on. It specifically says find the length of the missing sides using the Pythagorean theorem. So I'm going to write the Pythagorean theorem. A squared plus b squared equals c squared. 5 squared plus 5 squared equals x squared. I'm going to give you a moment to try that, please. (25 plus 25 equals x squared). X squared equals 50. Square root both sides. Break it up into a perfect square and a non-perfect square. And the answer, 5 root 2. Okay, let's take a look at the next one. So go ahead and use the Pythagorean theorem on this one. I'm going to wait a second while you do that. A squared plus b squared equals c squared. 7 squared plus 7 squared equals c squared. C squared equals 98. Square root both sides. You wind up with 49 and 2, and it's 7 root 2. Okay, let's take a moment and notice that in this scenario, both of these sides, this is 5, 5, and 5 root 2. In the other example, this was 7, 7, and 7 root 2. Okay. Now in the bottom one, this one's a little more difficult because we have this 8 root 2. And the 8 root 2 has to go in the C spot for the Pythagorean theorem. So it's going to be 8 squared plus b squared equals 8 root 2 squared. This gives me 64 plus b squared equals, now be careful here, but 8 root 2 times 8 root 2, 8 times 8 is 64, root 2 times root 2 is plain 2, 64 times 2, 128. I would subtract 64 from both sides and wind up with b squared is equal to 64 and b is equal to 8. So notice again, in this case we have a special right triangle because two sides are equal, and then the length of the hypotenuse is represented by a certain number. Let's take a look at the notes on the bottom. Here it says, what do you notice? The two legs are the same number, and the hypotenuse is the same number with a radical 2. Imagine that. That's simple. Okay, now we're going to move on to the next worksheet. So notice, it says this is a special right triangle with the complementary angles in a ratio of 1 to 2. Now if you think about that for a second, this is going to be 1x and this is going to be 2x. What are the angle measures? I'm going to write 1x plus 2x plus 90 equals 180. 3x equals 90. X is equal to 30. So that means that this angle is 30. And the other angle would be 2 times 30, or in this case, 60. So I'll fill in a little 60 right there. Now, this is called a 30, 60, 90 right triangle. So let's take a look. It says find the length of the missing sides using the Pythagorean theorem again. So I'm going to write a squared plus b squared equals c squared. Notice in this case the 5 is my a or b, it doesn't matter, and it's equal to 10 squared, or my hypotenuse. So this gives me 25 plus b squared equals 100, b squared equals 75, and I'm going to break that down into 25 and 3, and I wind up with, think about it for a second, 25 and 3, it goes into 5 root 3. So that's this side right here, 5 root 3. Okay, let's take a look at the next one. Ooh, this looks like a pattern's forming. So Pythagorean Theorem, a squared plus b squared equals c squared. I'm going to use 7 root 3 plus b squared equals 14 squared. Now, since you all know your perfect squares, 14 squared is 196. B squared plus 49 times 3 is going to be 147. You subtract 147 from both sides, you wind up with 49, and b is equal to 7. So we have a 7 right there. Last example. So Pythagorean Theorem again, please. A squared plus b squared equals c squared. 8 squared plus 8 root 3 squared is equal to c squared. This gives me 64 plus 64 times 3 is going to be 192 equals c squared. C squared equals 256. And then the square root of that, because you all know your perfect squares, is going to be 16. So this winds up to be 16. Now, you can notice some things in your pattern for the 30, 60, 90 right triangles. If you notice this number and this number, in this case the 7 and the 14, the number 5 and the 10, and the number 8 and the number 16 all have something in common. Let's take a look. The hypotenuse is always double the length of the side across from the 30-degree angle, and the length of the side across from the 60-degree angle is always the same length as the leg with a root 3. Okay, one more thing to copy down, please. Either on the bottom or on the side of your paper. I don't really care. But I'd like to see 2 different triangles. One that looks like a 45, 45, 90 right triangle, and one that looks like a 30, 60, 90 triangle. So notice this is 30, 60, 90. This is my 45, 45, 90. And there's a shortcut here. Most people will refer to this as x, x, x root 2. And then for the other triangle, this would be x, 2x, and x root 3. Thanks, and I'll see you soon.